2 of 7.2. So we're going to start right off with a definition. It says the reference angle of an angle in standard position is the positive acute angle between the horizontal axis and the terminal side. So today I had you do the table talk on purpose. It is a positive angle between 0 degrees and 90 degrees. A reference angle is a positive angle between 0 and 90 degrees. And it's between, what I mean horizontal is the x-axis. So as we do these, and it'll become apparent by the end of this set of notes, like why we need to do this. And then we'll use them in later sections as well. Let's go ahead and make 4 coordinate grids. So again, a reference angle is an angle positive between 0 and 90, and it's from the terminal side to the x-axis. So it doesn't matter which quadrant I'm in, I'm just going to go from the end of the angle until I hit the x-axis. Never, never is it with the y-axis. I always have students from the fourth or third quadrant try to do that. I'm like, nope, that's not it. All right, so let's pick an angle in the first quadrant. So this one's not very interesting because my reference angle is how far is the terminal side to the x-axis. And we call the reference angle theta prime. I'm going to write that out for you. We call it theta prime. Not Optimus Prime, theta prime. My boys were really into it. I used to say, robots meet the eyes, and they'd laugh after singing the song wrong. I was like, and then now I do it just because it's funny that I say it wrong. But anyway, my mind wanders places. So in the first quadrant, let's say in quadrant 1, theta prime is theta. The reference angle equals the angle. It is itself. All right, let's draw a second quadrant angle. And I'm going to make up a number this time. Let's call it 120 degrees. Theta prime is from the terminal side of the angle until I hit the x-axis. This is theta prime. How many degrees is theta prime here? How far away is the terminal side to the x-axis here? Yeah, it's 60. Right? It is 60. So how do you find it? In quadrant 2, you take 180 degrees minus the angle, and that'll give you theta prime, the reference angle. Notice, a reference angle is positive between 0 and 90. In the first quadrant, the reference angle is the same as the angle. In the second quadrant, you just take 180 degrees minus your angle, and that'll give you your reference angle, theta prime. All right, let's draw one in the third quadrant. So let's say theta is 210 degrees. So I want you to notice that yesterday, and I broke this up over 2 days, because I wanted to make you sure you were solid with making sketches. Okay, because making an accurate sketch of an angle is critical for everything else that we do. So I went ahead and chunked it into small bits for you so that we would do just fine with this. So now theta prime is the distance from the terminal side to the x-axis. So it's this teeny tiny little angle. Can anybody tell what is theta prime here? 30 degrees. Well, how did you do that? Yeah, and I like how you said that. You have to do the angle minus 180 because I need it to be positive, right? A reference angle is a positive acute angle. It's positive between 0 and 90 degrees. So you would take your angle, because the angle is bigger than 180, minus 180. All right, let's do the fourth quadrant. Oh, let's take smack in the middle, and theta is 315 degrees. So theta prime is from the terminal side to the x-axis. Never, never is it to the y-axis. So, can anybody figure out what is theta prime? What's the actual number? .45 degrees. All right, well, how did we figure that out? Good job. 360 degrees minus your angle, we'll call theta, and that will give me theta prime. So here's the big idea. I don't memorize any of this. All I remember is that a reference angle is from the terminal side to the x-axis. Then I just figure it out, okay? Let me say that one more time because this is going to help us do everything that we need to do. Our reference angle is from the terminal side to the x-axis. Once you make a good sketch, you just figure it out. Yeah, did you have a question? You figured it out. Awesome. Okay. All right, so here's what I want you to do. In example 1, you are asked to make a sketch and determine the reference angle. So I'm going to pause and give you about 2 minutes head start. Make a coordinate grid and sketch your angle. Everybody should be able to do that if you were here yesterday. So make your sketches. If you figured out what a reference angle is, then do that component as well. If you're still a little shaky, you can wait for me. I don't know if some of you are taking AP exams, but I put here, I highlighted because I have IB calculus and AP calculus, so I've highlighted mine. But if you have any others and you're not sure what day you're taking an AP or IB exam, I have the calendar up here for you. You're welcome to look at it when it's homework time. when you get to letter D, reference angles are positive, okay? Remember, reference angles are positive. All right, I'm going to do letter A, just for those of you that might be struggling. 150 degrees, that's more than halfway. Then my reference angle, theta prime, is how far am I from the x-axis? So I take 180 minus 150, so theta prime is 30 degrees. Can you give me thumbs up? Did we get that? Did you get 30? Can I see more thumbs? You got it? All right, awesome. All right, letter B, 330 degrees. Whoa, that's really far around. So theta prime is how far am I from the x-axis? I'm almost a full rotation. So theta prime is also 30 degrees. All right, 225. That is exactly halfway into my third quadrant. I want you to notice how I'm labeling theta, and I'm drawing an arc. So make sure you're doing that as well. Then theta prime is from the terminal side to the x-axis. Theta prime is from the terminal side to the x-axis. Since the reference angle must be positive, I put 225 first. So that reference angle is 45 degrees. Now, I'm trying to plant seeds for the unit circle, so I'm trying to keep these 30, 45, 60. But I hope you know, I mean, I could have 100 degrees, I could do 127 degrees, I can do any angle, but I'm trying to pay it forward for where we're headed. All right, negative 150. So now I'm going to go clockwise this way. And no matter if I'm doing a positive or a negative angle of rotation, theta prime is still how far away am I from the x-axis. So I'm just going to do 180 minus 150, because that was negative. The reference angle is positive. So I want you to write a little note here. Reference angles are always positive. And they're a number between 0 and 90. So now we're going to make a beautiful connection, okay? I'm super excited for this. So now we're going to connect this to our special right triangle. Okay, I'm planting some fabulous seeds here for what we have happening. So I want us to use the graphs from above, and we're going to do these without touching a calculator, and I want to find the tangent of 150 degrees. So watch what I'm going to do. I'm going to take this angle, and you understand that the reference angle was 30 degrees. So what I'm doing is I'm going to drop a perpendicular. Okay, I'm going to drop a perpendicular and create a special right triangle. Well, in a special right triangle, we can say across from 30 is 1, the hypotenuse is 2, and across from 60 is square root 3. The thing is, I'm in the second quadrant, and so I actually went left to the square root 3. So what you're going to do, okay, and again, we're going to do this more in the next lesson, but for now, you're going to take your sketch, and it's going to create either a 30-60 or a 45-45 right triangle. And so you're going to have to remember those two special right triangles. And then you're going to have to do that I went left. So this part is negative. I'm up. Across from that 30 is up. The hypotenuse is really representing the radius of a circle. So the radius of the circle can't be negative. So the hypotenuse will never, ever be negative. So I'm kind of planting seeds for my unit circle. So I want you to kind of think here a moment that it's like I'm making a circle where the hypotenuse is the radius. All right, so remember, so, ka, toa. Tangent is going to be the opposite of the reference angle. So that's 1 over negative square root 3. Well, I can put the negative up in the top, and I can rationalize and make that multiply by square root 3 over square root 3. So that's negative square root 3 over 3. Do I need to put on here your special right triangles? Maybe let me do that. You're supposed to remember these now. We had a quiz on this, and you all did fantastic. Remember those? Okay. So now let's look at letter B. Here's my 330 degrees. And maybe this time, let me put it back on the coordinate grid. Maybe this will make a little bit more sense if I do it like this. So do you remember that reference angle was 30? So I'm just using from directly above this. So we made our sketch. Across from 30 is 1, the hypotenuse is 2, and across from 60 is square root 3. So you've got to remember those 3 numbers. I'm right, so the square root 3 is positive, but I'm down 1. So I'm going to put a negative with the 1. So you have to pay attention to left, right, up, down. The hypotenuse really represents the radius of a circle, so the hypotenuse is always positive. So now I'm going to do the sine. The sine of the reference angle is going to be opposite over hypotenuse. So that's a negative 1 over 2. You get that sine is opposite over hypotenuse, and you're always going to come from the reference angle. You remember we had a quiz on the special right triangles. If they are, like, so if I just randomly pick one from across from the 30, I technically could, right? I could make that 5, that'd be 10, and it'd be 5 square root 3. Well then, if I did opposite, that'd be negative 5 over 10, still reduces. So it's easiest to pick 1, because it's already reduced. But you're right, there's infinitely many I could pick. Okay, let's try letter C. So 225 was in this second quadrant, and it was exactly halfway. So this is going to create a 45, 45 right triangle. So it would go 1, 1, square root 2, but I'm left 1 and down 1. Again, my hypotenuse represents the radius of a circle, so the hypotenuse is always positive. Now I'm going to use ka, adjacent, and where we're coming from is the reference angle. The reference angle is always from the x-axis to the angle, to that hypotenuse. So ka is going to be negative 1 over square root 2. So I'm going to multiply by square root 2 over square root 2. That's negative square root 2 over 2. All right, let's do the last one. tangent negative 150. So we're going to look where that angle was. And remember the reference angle was 30. Across from 30 is the 1. The hypotenuse is double, and the across from 60 is the square root 3. So this is left and down. And I'm going to use TOA. So it's opposite, negative 1 over negative square root 3. Two negatives become a positive. And I'm going to multiply by square root 3 over square root 3. Yeah. Do you see that's the hypotenuse? The hypotenuse represents the radius of the circle that we're not drawing. And a radius can't be negative. So the hypotenuse will never, ever be negative. That's a great question. Okay, so now I'm going to show you something about the 4 trig functions. And there's something I've always told my students. All students take calculus. All students take calculus. And let me explain what this means, okay? All students take calculus. In the first quadrant, x is positive and y is positive. So here, all trig ratios are positive in the first quadrant. In the second quadrant, my x values are negative because I go left and then I went up. So guess what? The sign is positive. Because remember from so, it'll be opposite. Opposite will be the up. So the sign is positive. So that's what the S stands for. Sign is positive. Down here in the third quadrant, x and y are both negative. And so what that stands for is tangent is positive in the third quadrant, but that means sine and cosine are negative. Then in the fourth quadrant, x comma y, I'm to the right, so x is positive, but y is negative. So cosine is positive. So another thing you can do is you can just find sine, cosine, tangent of the reference angle and then do all students take calculus. So what I want to do is I'm going to create just a couple of what is this, day 2? Day 2 video. Okay.